Okay, so the applications of log functions, especially and by association exponential functions, are going to be found in a lot of the physical sciences. I am going to today introduce to you a variety of different formulas. Sorry, that's a typo. I'll fix it in a second. I'm going to provide a variety of formulas that can be used to describe different circumstances, whether it is acid or base levels in pH, whether it is talking about sound in decibels, whether it is how destructive an earthquake is, so on and so forth. Where can you find, I'm going to quickly go to our Brightspace. If you look at your formula sheet, I hope you still have a copy. If you don't, you can ask me, or you can print it out here. The formula sheet on the back has 1, 2, 3, and by association, for 5 different questions that could be asked, okay? As part of our exponentials, I don't think we have done any questions on half-life. So maybe I will raise that as a point after our practice examples today. I expect half-life to be not a surprise to you, but you've seen it before, whether it's in science or in grade 11 math. And so if you need a breather or if you need a refresher, ask me after today's lesson and we'll do an example together. Okay? And I'm excited for that because that's literally half of toxicology in university. Let's talk. You will see that because we are using logarithms, everything is based on a base 10 scale. It's just easier that way to talk about. Okay? Consider, let's read. The pH scale is for acidity and by alkalinity. So for those of you who are doing chemistry, pH or POH, okay, is defined as a pH level equals a negative log of some concentration. If you don't know what H plus is, don't worry about it. Long story short, it is how many hydrogen ions are inside. And this is the measurement. All of that will essentially be provided for you, like you will see them within the question, so you don't have to worry too much, especially if you're not doing chemistry. But here it is. Tomato juice has a square bracket concentration of approximately 0.003, and if I were to be proper, that should be moles per liter. What is the pH? That's it. You look at your formula sheet, which I might as well download because it will show up on our handout. Oops, give me a second. Yes, Kelly?
Do we do the same thing that we do in chemistry class where the number of decimal places in the concentration is the number of significant digits in the
Yes, but if you see questions like this on the test, I will typically ask you to round to some decimal places, like usually 2 decimal places. Sig figs is unfortunately not our greatest concern, so I'm okay. As long as you round to what we ask, your communication marks will be totally fine. Okay. Oh, that's grade 9. Here we go. So yeah, what is the pH? Following this formula right here, we just plug it in. We have pH is equal to negative log of whatever concentration that is. And so we have pH is equal to negative log of 0.0003 moles per liter. That's it. Simple, right? Even if you don't understand what's going on, you can at least follow along how plugging into the equation or plugging into the formula is not that difficult. Log of 0.0003. The pH would be approximately, let's do 2 decimal places just to start, 3.52. And pH doesn't have a unit. Yes?
Is that there like a missing zero after the decimal place in the H plus concentration? Because on like the pH scale, it said it should be about 4.5 and not 3.5.
I know. Think about it. 10 to the power of -3 is 0.001, and 10 to the power of -4 is 0.0001. So 0.0003 is bigger than that, but smaller than that. So it is somewhere between.
So the scale, where it is on the scale is like,
What do you mean?
because they have that arrow for tomato juice at about pH of 4.1. And we just calculated like 3.5.
Oh, sure. I see what you mean. So you're talking not about the actual calculation, you're talking about this thing right here.
Yeah.
You're right. Let's say the water was so reduced from the tomato juice that it became extra concentrated. That's my bad. Okay. I'll put a little note saying wrong. Okay. Liar. How dare you? Okay. Blood has a hydrogen ion concentration of 4 times 10 to the power of -7. What is a pH? Same thing. Just because I give it to you in a different number does not mean the formula changes. It's literally 4 times 10 to the power of -7. If you don't like that, you might be wondering, how do I plug that into the calculator? Sure, you can do this into the calculator. Or if you know your sig figs, 1, 2, 3, 4, 5, 6, 7 into your calculator. That is negative log 1, 2, 3, 4, 5, 6, 7. That's approximately 6.397. So it's going to be rounded to 6.40. Is that wrong here too? Yeah, I guess so. Maybe we got a little different. I don't know. Just bear with me, okay? Maybe the picture, maybe the numbers that I found was POH or something, and here it's all pH. I could be wrong. That's my bad. Same thing. Please consider the reverse though, just as an exercise. If I gave you the pH as 3.6, what is the concentration? Using what we've learned in class, you should be able to convert this into an exponent. Okay? Best way to do it is, let's get rid of the -1. Divide both sides by -1. We get -3.6 equals log of something. Which means 10 to the power of the answer equals that. Okay, so 10 to the power of this exponent equals the answer h. Oof. Therefore, 10 to the power of the exponent is equal to that, which is equal to, yes?
Is there a way to do it without using, like, thoroughly using the line?
pH?
Figure out what the concentration of hydrogen ions is, like, without rearranging the exponential.
I would imagine it would be very difficult. Because there's no real way to calculate without a calculator, essentially. That's what you're asking, I think. Okay, so approximately 0.00025 moles per liter. Since I'm going back to concentration, there it is. Okay. The next couple examples, I'm going to try to describe to you how that makes sense. I'm not going to go too much into the science of it. We're going to see the formulas being used. And from there, let's talk about how I could twist these questions to make it harder for you. Okay, here we go. Common sound levels are indicated in a decibel scale, dB, capital B, lowercase d. Please forgive me, this is actually just a single log, okay, not log. As sound travels, the loudness you hear decreases exponentially because the energy of the sound wave must cover an exponential amount of space. And that's a really good scientific point. The difference in sound levels can be found using this equation. A single decibel difference is 10 times log of a ratio of the intensities. You don't have to worry about the units for intensities. You don't have to worry too much about the units for decibels as long as you write it. Consider, most important, matching the first decibel with the intensity on top and the second decibel with the intensity on bottom of my fraction. That has to be consistent. The sound of a normal conversation is 60 decibels. How many times as intense is it compared to a whisper? So let's pretend I have dB of 60 minus 30, which establishes the intensity in the numerator to be from the conversation and the intensity of the denominator being the corresponding to the whisper. 60 minus 30 is equal to 10 times the log of I2 over I1. How many times as intense is it? Well, let's do it. 30 equals 10 times the log of the ratio, which means 3 equals the log of the ratios. Once again, using what we know of logs with exponents, the only real, I think, the real way you can solve it is turn this into an exponent. 10 to the power of 3 is equal to the ratio of these two. So the answer is 1,000.
It's technically 1,000 to 1.
Exactly. Exactly. Do I care what I2 is or what I1 is? No. The question is how many times as intense? In other words, all they want is the ratio. The intensity of the conversation is 1,000 times as intense as whatever the intensity of the whisper is. End of story. That's all you need. Therefore, a conversation, I'll type this. A conversation is 1,000 times as intense as a whisper. There. So I'm going to leave B to you, just so we save time and give you more opportunity to wrestle with this. Consider part B. A ratio of intensities of two sounds is 32 decibels. Sorry. It's not decibels. That's a misnomer. Or sorry, what am I saying? That is a misleading piece of information. The ratio of intensities, in other words, I2 over I1 is 32. If the louder sound is 85, what's the decibel of the other sound? I'll leave that to you. Okay, give that a shot. You probably can. That's essentially what it is. Just knowing, understanding how to match, how to plug in, pulling information out from the question. It should be fairly straightforward, but give it a shot before you leave today. Yes?
Will the formula be given on our
It's on your formula sheet, which is provided for you.
And then the only two logbook you need to know would be
So these 4 are given. If you find others to be very useful, you might want to practice them a lot and memorize them. These are the only ones, your only log laws that are provided.
Can the other ones be like simply derived?
Essentially, yes, it can be, but these are the only 4 provided. Any more will have to be born from your practice.
So like, would you, as someone who doesn't like memorizing, would you advise starting picking up more? Is it necessary?
Sure. There are some that are useful in certain situations. I think I mentioned a couple. I'll go back to it. Come and ask me, and we'll take a look at which ones I think are useful for you, okay? Let's continue. Another one that's fun, earthquakes. Once again, this is an error. I don't know what's happening, but the log repeats itself, so erase one of them. Magnitude of an earthquake is essentially calculated by seeing how intense your earthquake is compared to a quote-unquote standard low-level earthquake. So the lowest detectable earthquake's intensity versus the intensity that we feel, that's how they calculate your magnitude. Anybody know, without looking at the picture, what a safe magnitude number is? Like, what's the threshold between should you be worried versus should you not be worried? Anyone know? It's a number that you typically throw around if you grew up in an area that has earthquakes. Yes? Yeah, about 4. How did you know? That's right. So something that happens when they feel it, right? It's actually a famous, well, not a famous line. It's a line from a movie. I'm not sure if you've seen. It's a really old one with Will Smith, Independence Day. Sort of seen it? That's like 2001. That's a long time ago, but it was revolutionary at the time because it was such a fun movie. Had the same guy that comes out from Jurassic Park, that really tall dude. I forget his name. Yes, he's there. A lot of fun people are there, and as a line, they wake up and they feel an earthquake. They're like, what's going on? And the person that's like, it's not even a 4-pointer. Just go back to sleep, right? And then when they wake up, they realize the earthquake was because it was like it's a freaking UFO sitting in the sky. 4.0. 4.0 magnitude. Anything bigger than that, you might want to watch out. When you get to 6 or 7, it's really, really dangerous. So here's a scale for those that are interested. A 4-pointer is around here. A minor earthquake, it can be felt by humans. Okay. Level 5, some things rattled from the shelves. Some, weak homes might have property damage. It won't be like, ground breaking apart and people, being separated and they can't talk to each other. I mean, it's not going to be like that. It's not like the movies, but you will see some damage. Starting from 6 and up, it is similar to, I'm just going to say an atomic bomb that has been exploded in terms of damage, right? So anything greater than 6 is worth being really concerned about. In terms of 6, though, if you read here, if that is a 6, how much more intense is that earthquake? Can you do the math? The base is 10. Not 6,000, but this is base 10. 1 million times more intense than a standard earthquake is pretty destructive. You think about it like that. Okay, so let's do some questions. Another typo, how many times, not TMs, okay? How many times as intense as a standard earthquake is something measuring 2.4 on the Richter scale. Long story short, times as intense means what is the ratio of this earthquake if the Richter scale measures a magnitude of 2.4? That's the question. So we have 2.4 equals log of that. So the answer is, turning this into an exponent, 10 to the power of 2.4 is approximately 251.19 times as intense. This is, what is the magnitude of an earthquake 1,000 times as intense as a standard low-level earthquake? So they're asking for a magnitude this time if the ratio is 1,000 times as intense. That's the question. So I'm going to leave that to you. If you can solve that, that's great. I'm going to add a third question saying, what how many as intense is an earthquake measuring 8.1 on the Richter scale compared to an earthquake measuring 4.0. So here is a question that's not asking you to just plug in the numbers, but you might have to do some calculations with 8.1 and 4.0 and then having to compare them. So here's a bit of a challenge question. This is what I mean by sort of twisting. In the same breath, I'm going to do a little twist on the sound. If you want to go back to the first, I'm going to put a little question here. Okay, part C. How many times as intense is a concert measuring, I don't know how loud a concert is. Let's just say 300 decibels. I don't know.
That's like jet engine.
Yeah. Okay, I don't know. You're at like, yeah, sure. Whatever their most recent alternative. I don't know. Nowadays concerts are pretty intense. And it's like really, really painful. I just say it's like, I don't know, you went to Kendrick Lamar and all they do is like scream into the mic because they're rapping really, really hard. Hey, how many times is intense is a concert measuring 300 dB? As
It is impossible to generate a sound as loud as that.
okay, fine. 120 decibels. Oh man, is there a way to twist this up?
Apparently it takes 12 seconds for 120.
Okay. And you're at a concert, measuring as Is this even possible? This or that, but that gives you that as something, which is a that is 10 to the power of something. Is that even possible? I'm curious to know if that's even possible. Let me try it. I'm gonna leave that. Would you please try these questions first, especially part C, and while I give the other one a try?
5 dB.
Just 5. I'm not going to talk about intensity because that gets to like power and watts and stuff like that. I think intensity. Oh, intensity. Sorry, intensity. Okay, give me a second while I pause this video. No, I think I might have to change it. How many times is this going to as a whisper? If the intensity of a conversation is as a conversation, if the intensity of a conversation the intensity of a conversation is 1,000 times would that work? 1 second. I don't think I can make this any more tricky. I'm gonna erase this. But let's just stick to this one. Compare that. So for part C, if you are trying this, there are a couple of ways you can get around it. You could use the magnitude. You can also, if you're savvy about it, think about the equation of the magnitude and consider how that could be manipulated to look like the sound decibel. The same can apply, but I'll do it in a more straightforward manner. Give it a shot, and we'll call it a day.